I will begin with a word of prayer as I get up here. All right. Dear Heavenly Father, we thank you for this day. I thank you for these students. Again, I thank you for the privilege we have to meet together, study your creation. Just pray that you'd give us insight and just help the students if they're struggling, just to be encouraged. Lord, in your name I pray. Amen. Okay, so if you guys have a question about a particular homework problem, you're welcome to ask. In terms of theory, we've got all the tools in front of us, right? So I could work another example. Here's one. So there's a mixture of graphing in your homework. There's a fair amount of graphing in this week's homework, right? So the intention of the graphing problems is to make sure that you leave this homework having a firm understanding of this is what an exponential looks like and this is what a logarithm looks like, right? You should get these two things from the homework, if nothing else. And so here's one. We could say y equals to, 2 plus log base 3 of, x minus 4. How would we graph? Yep.
I do have a question. Why is log base 3 or log base 4, 5, or 6, or whatever number is the base there? Does it matter at all?
Well, yeah, I mean, if I choose a different base, it's a different function.
Okay.
So, I mean, they're different. It's like, we typically use whole number bases unless we're talking about like base E, because base E is special. But there is like a homework problem somewhere on like base 1/2, which is, weird. But we can talk about that one in a minute. So the basic thing here is we begin. Basically, here's how I think about it. I think about y equals log base 3 of x, right? That's my basic graph. I start with that, then shift right, 4. That gives me the y equals to log base 3 of x minus 4, and then I go up 2, and that's your graph. So just to kind of sketch it, my basic graph is log base 3, which looks like this. It's got this x-intercept of 1, 0, right? And it's got, we can track a couple things. So 1, 0 is here, and if you go over to 3, you've got 3, 1. You see, because log base 3 of 3 is equal to 1. So these are 2 points on y equals log base 3 of x, yeah? And what else is characteristic of log base 3 of x? It's got a vertical asymptote at 0, right? That's kind of a critical feature. So maybe we should let's try to keep track of what happens to the vertical asymptote at 0, right? And let's keep track of these 2 points under our transformations, right? So shift right 4. So if I just foolishly draw it on here, shifting right 4 is going to move my vertical asymptote over here to x equals to 4, whereas before it was x equal to 0, right? And it just takes the whole graph and shifts 4 units over. So it's going to look something kind of like this. All right? And my point 1, 0 moves over here now to the point 5, 0, right? And this point up here, I'm moving over 4 units, so 7, 1, right? So what I've graphed in red is y equals to log base 3 of x minus 4. So it's just the logarithm graph shifted 4 units to the right, right? And then I take that and I shift that up 2 units. That's my graph. So I'll draw the answer down here. So my graph, it's going to have a vertical asymptote at x equal to 4. And it includes the points, I'm going up 2, right? So my 5, 0 maps to 5, 2. And my 7, 1 maps to 7, 3. And the graph is something kind of sort of like this. All right? So we can graph things like this using transformations of graphs. We start with the basic logarithm and kind of move it around. What is the shape of the logarithm, by the way? Like so this is, my graphs never turn out quite right. Like if this was exactly right, it should resemble more the picture for like the logarithm looks more like this, you know? I mean, that's not even quite right. If I had some graph paper, you know. The point here is if we're working base 3, what's the graph of the base 3 exponential look like? It's got y-intercept of 1, right? And then it goes up to 3 when we're 1 unit over, right? And when we get to 2, it's all the way up to 9. So it's kind of like up here-ish. And then if I'm at minus 1, it's at a third, so it's like here, you know? If I'm at minus 2, it's at like a ninth, right? So the graph of 3 to the x looks something kind of sort of like this. And see, log base 3 is just this shape, right? Reflected across the line y equals x. So a careful graph of log base 3 should have this same kind of shape, turned sideways, right? A careful graph of y equals log base 3, it's not this exactly. It's more, you know, I have this point, and instead of having this point up here was what, 1, 3? So you've got 3, 1. Right? And I've got this point up here was 2, 9. So there'd be a 9, 2. Well, this was 3, so it's here-ish. You know, and so it's a careful graph of this is something more like this. So I never get it quite right when I just, you know, if I did this exactly right, they should be reflections of one another across the line y equals x, right? That's the real McCoy, as best as I can do on the fly here like that, for y equals 3 to the x. So I'm content to work with a sloppy facsimile of it for these kind of transformation problems, right? Your homework, they have graph paper with points on it, so you can be more precise in terms of your interpretation of things, right? Something I'd like you to notice about this, though. Number 18 in your homework is kind of tricky. I think it was number 18. Number 18, it's very, yeah, number 18 is kind of sneaky. It gives you this graph, and then it's like, write an equation for the graph given. The graph represents an exponential function f with base 2 or base 3 translated and or reflected. So it's kind of vague, right? It just gives you a picture of some points, and you're supposed to, you know, do some detective work to figure out whether it's base 2 or base 3, right? So my hint for you for number 18, to try to help you with, so for number 18 hint, you know, y equals 2 to the x versus y equals 3 to the x. They're quite different in the way they go up. Like, check this out. So with the 3 to the x one right here, right? You've got this, if you look at it, there's this jump here, right? You go 1 over, and you go how many up? We go 6 up, right? And then if you look at this step right here, what's this one going? This is 1 over, not 3, but 2 up, because 3 minus 1, right? In contrast, if you look at the y equals 2 to the x graph, How's that one behave? So 1, 2, 4, so if you look at that one, I mean, it keeps going, right? I'm trying to compare them. All right, so if we keep going up here, this point, so here's 2, 4, up here is like 8. So up here is the 3, 8 point on 2 to the x. So look at how the 2 to the power graph works. See, you go 1 over for this one, and how much do you go up? 2. You go 1 over, how much do you go up? 4, yeah. Because 8 minus 4. So if you look at it, you can calculate this in general, right? If we do 3 to the n plus 1 minus 3 to the n, that's 3 to the n times 3 minus 3 to the n, which is equal to 3 to the n times 3 minus 1, which is 2 times 3 to the n, versus 2 to the n plus 1 minus 2 to the n gives me 2 to the n times 2 minus 2 to the n, which is 2 to the n times 2 minus 1, which is 2 to the n. So if you look at how the 2 to the x function and how the 3 to the x function increments itself as you go 1 unit over on the graph, it's really different, the behavior. The 3 to the x function goes like 2 times a multiple of 2 times the power of 3, right? Whereas the 3 to the x graph goes 2 times, the 2 to the x graph just goes a multiple of 2, right? It goes increments of 2, 4, 8, and so forth. We went on. Whereas the 3 to the x graph goes in steps of 2 times the power of 3, right? Like we go 2 times 3 to the 0 for the first step, and then 2 times 3 for the second step. If I had a bigger board, and if I was taller, I could put a mark way up there in the blue, right? And I would have the point 3 comma, like the next one up there is what? It's 327, yeah? And 27 minus 9 is what? It's 18, right? And 18 is 2 times 9. That's not an accident. So what I'm telling you, this is like a super big hint for number 18, is if you look at the points on the graph, you can easily deduce whether it's a 2 to the x or a 3 to the x in terms of how it grows. Right? Just compare the growth rate for your exponential to what I've just shown you. You should be able to figure out which one it is pretty easily. And also from the general shape that you're given, you can see that it's not reflected. Right? Because if you look at the graph, at least the one I have in my homework, it still looks kind of sort of like it's it's a little bit different place. But here, let me make up a worse example for us. We should do some things that are harder than the homework every so often. Here's one. So you're given the graph as follows. You're given the following graph. You've got an exponential function, yeah? It goes through the origin. It's got this horizontal asymptote like this. All right, and so I'm telling you that points on the graph include 0, 0. This is minus 2. And over here, you've got the point, let's say 2 comma 6. Now here's the question. Find A, B, and C such that y equals, let's say, b plus a to the x minus c gives this graph. So I'm going to call this whole thing the function of x. I'm trying to find a function which has that as its graph. Now, I suspect that the answers might, well, I think the answer is unique. I haven't thought too hard about that, so, I know that there is an answer. Is this the only answer? I think so. I'm not 100% sure. I'm about 95% sure. Okay, so you guys tell me what B is. You all should be able to tell me what B is. What's that? -2, right. So B equals -2. See, because since horizontal asymptote y equals -2. And see, so this formula, what happens to the formula? When x gets sufficiently like large and negative, what happens is if you put in like -1,000,000 into this, let's say, that becomes a really, really small number, right? So this whole formula drops back to just b for really, really negative x, which means we should put b equals to -2 to match the horizontal asymptote. Just like in our other example over here. Oh man, we haven't done one. If we go back to the first example we did last class and look at what addition did to the like example 1 from last class, you can see the intuition that I wanted you to get intuition from that example to see this, you know, and some of you have it, some of you don't, and that's one of the things you want to pick up in the homework. All right, is that kind of intuition. Yep.
What is the ST?
Such that.
The what?
Such that. It was an abbreviation meant to save me from writing such that. So you've ruined it. I expect that from the Mean Girls, but see, it's okay. If you have been here, you would know that I've been calling them the Mean Girls because they're mean.
Oh, I've been here.
You've been here?
Yeah, the whole time.
The whole time? Okay. I forget when I decided to call them the Mean Girls, but I don't know. So they'll let you be part of their group? We're fringe? No. What is your clique? I mean, are you skaters? Are you? What are the appropriate cliques to mention in high school? I don't know. Like, what are the classes that we're dividing ourselves up into arbitrarily? The jocks? Oh, okay. Yes, that's time honored. Nerds. Okay, yeah.
Love nerds.
Love nerds. They're delicious.
Candy is so good.
Yes.
I eat like 6 boxes of them, man.
I foresaw this comment. Let's see here.
Talk about the candy?
No, I knew you were going to talk about the candy. Let's see here. Okay, so what do we do next? I mean, great. We figured out -2 is b. What next? We have 2. Oh, I don't know. I don't think C or A are anything pretty. This is an ugly version of number 18. This is an uglified. Ugly. How do you spell uglified? I don't know.
F-I-E-D.
Uglified. I feel like there should be a Y in there. Uglified. There we go.
You're making it up, so spell it however you want.
Oh, I can spell it however I want. Let's see. Uglified. The way you spell uglified is. Well, there's any number of jokes to put there, but I'll behave. I'll behave.
Oh,
No. Every day in the news is a joke, so just watch the news. Okay, so this is the thing. We know that f of 0 is 0, and we know that f of 2 is 6, right? But what do those tell us? Those tell us that 0 is equal to -2 plus a to the minus c. Yeah, and the other one is -2 plus a to the what? Not minus c, but 2 minus c, right? So this is something different that we're facing here. This tells us, this equation gives us that a to the minus c is equal to 2. All right, and then the other one gives us that a to the 2 minus c is equal to 8. And I said this one was ugly, but maybe last class I put 2, 5 there. It made it really ugly.
Yeah.
You were not in the last class. Stop this. Although that would be funny if you came to like the earlier section, you know.
If we did that, would you count attendance?
Yeah, I mean you can attend another section in the day if you want to. There's usually room, but this is the best section. Like the lecture's better in here usually. Yeah. Somehow we get distracted more in here, but we cover more somehow. I don't know how it works, but
We cover more, but we weren't distracted.
no, seriously, I covered like a lot more in here than the other sections. I've been telling the other sections that they should watch Wednesday of this section to see like most of the homework solved.
We're good.
Okay, so look here, guys. Look here. This is we haven't faced this before. And so the end of this class, like the last thing we focus on in here is systems of equations. So this is the first example in here that I can think of a system of equations. Because we have 2 equations and 2 unknowns, right? Equation 1, equation 2. Now, how do you solve 2 equations and 2 unknowns? You what? You don't? How dare you? How about we take the second equation, right? And we write it as a to the 2 times a to the minus c equals to 8, right? Because of laws of exponents. And then, this is how you typically solve systems of equations, at least at this kind of course. We do substitution. So we can substitute the first equation, a to the minus c is equal to 2 though. We're trying to solve both of these equations at once because we want the graph to go through both points. Both of these things have to be true at the same time. So anyway, this gives us a squared times 2 is equal to 8. I said this was ugly. That was false advertising. Actually, wow. You guys might have actually told me the right answer a minute ago. And I'm sorry, I should have made it uglier. False advertising, this is not at all ugly. Well, plus or minus 2, right? A squared equals to 4 gives us a equal to plus or minus 2, but why do I not put minus? Because we're looking for the positive base, which makes this graph, right? So because of the context, we get a equals to 2. Come on, at least let c be ugly.
No.
So we found our a, right? We found our b up here, right? What's c equal to? So we have 2 to the minus c equals to 2. Oh man, this one worked out nice.
Why are you so upset about
I wanted it to be ugly. It's not at all ugly.
I mean, we still got more time.
I know, but
You're trying to for yourself or for us?
so, man, this is not ugly at all.
Put this one on the test, and I'm sure.
So put this on the test.
Yeah, I told them no business.
Anyway, so by the one-to-one property of the exponential function, we get minus c equals to 1, which, as you said, c equals minus 1. So put it all together, the answer was y equals to minus 2 plus 2x to the minus x minus 1. But do you see what happens here if I change that point from 2.6 to like 2.7? So let me just allow me this. If I do the same problem, but instead of going through 2.6, I go through 2.7, it makes it way, way uglier. So basically all the math would be the same for this one, right? What the difference would be,
It looked like 2.8.
we get y equals minus 2. So it would still be this one. We still got we got the
No, because you got 2.7, should be 2.8. You know what I'm saying?
I mean, if we're gonna do the one that's ugly, should we just scrap the 2 altogether? So I can do something?
Well, I think that, I mean, so we still get a to the minus c equals to 2. We get a to the, I made it up, 2 minus c equals to 7. Which then gives me, you know, a squared times a to the minus c equals to 7, which would give me a squared times 2 equals to 7. And then all of a sudden I've got a squared equals to 7 halves. Right? And then how do you solve a squared equals to 7 halves? Well, that's not...
Can you take the root 2?
Did I do this right? Is that supposed to be 7 or is it supposed to be 9? That's supposed to be a 9, isn't it? Well, look here. So if I put a 7 here, right? Then I add 2. It should be 9, not 7, right? If I go through the math. So I get 9 halves. So this gives me a equals to, you know, 3 over the square root of 2, apparently, for my base. And then what's c? How do you find c now? Where my camera crew at? They took today off? Yeah, I guess so. So, so then, see, then we run up against 3 over the square root of 2 raised to the minus c power equals to 2. Now, what's the solution to that? See, like, this 2 to the minus c power equals to 2 was very fortuitous in my first quote-unquote ugly version of example 18. Right? It is, this is actually, so like, how do you find c there? What do you do? Can you solve for c? How would you find it?
Wouldn't you just
Where did you get 3 to the square root? 3 square root. Oh.
You got it, okay. Cool. What's that? All I did was I did everything over there, but instead of 2, 6, I did 2, 7. So like same equations, just I still get the 0, 0, so I still get a to the minus c equals to 2. But now instead of having a 6 there, I have a 7, which means I add 2 to the other side. I get 9 equals to a to the 2 minus c. Then I pull out a squared times a to the minus c. A to the minus c is still equal to 2. I plug that in. That gives me a squared is 9 over 2. I take the square root of both sides, plus or minus. I get a is, you know, plus or minus the square root of 9 over 2. But that's equal to plus or minus 3 over root 2. And so that's why I have this, because that's my a. And I choose the plus because the graph is definitely a positive base, you know. What does a negative base even look like? We don't know. No one asked this question. It is forbidden.
when you have to get negative c alone?
So my question remains, how do you find c? How do you solve for c here?
You have to move the 3 over 32.
Move the square root of 2 to the other side, but I'd still have a power of c if I did that. Yeah?
So you put power of 3 over square root of 2.
Ooh, I don't know how to do that either. What I do know is when I face something like this, if I don't like the exponential equation I'm dealt, and I want to turn it to an equation which is multiplicative, like what does the natural log do? What does the logarithm do? It changes exponential equations to equations which are just like multiplication and addition, you know? So if we want to change from exponents to sums and products, we just take the log of the equation. So I would take the natural log of this equation. That's what we should do. So if we take the natural log of the equation, then we can use properties of logs to simplify it.
I have a question. Why natural log and not log?
Well, you could use log base 2 or the common log. I just like natural log because it's natural.
How do we know when to use a natural log?
Yeah.
Naturally, you know. You can't go wrong. Like whatever log you use, it's gonna, it allows you to pull the C down.
Just like the way the LN looks.
Yeah, I like, it's one less letter to write. So that makes it the correct choice, right? So C,
But they both do the same thing, right?
natural log of 2. If we had chose a different log, right? If we had chose a different log, we would have got, like, if you used common log, you would have got common log of 2 divided by common log of 3 over the square root of 2. So, tell you what, let's pick 2 different people. Who's got calculator out? Somebody? You calculate it with the natural log, find the decimal number. Somebody else calculate it with the common log. I'll do the common log if no one else has got it.
Question, how can you calculate this by hand?
Well, with calculus, I suppose. So if I do the common log, I'll do that. I got myself a log of 2. So this is about minus 0.30103 divided by log of common log of 3 divided by square root of 2. That gives me 0.32661, roughly speaking. So if I reciprocate that and multiply it by 0.30103, I get myself about 0.9217. What did you get with yours?
0.9216.
Okay. So 0.921.
No, 0.9217.
9217. So it doesn't matter whether you use the natural log or use the log. They both work out the same. The reason for that is the change of base formula. If you want to change the base, remember, like log of blah is equal to natural log of blah divided by the natural log of 10. That's how to change base from natural log to common log. And so if you look at it, you've got the same conversion ratio in the numerator and the denominator, so the compensating factors cancel. And basically the ratio of logs in different bases are equal. So fun fact, log base a of x1 over log base a of x2 is equal to log base b of x1 over log base b of x2. So this is, here's an identity that, see, I have not told any of the other sections of college algebra this. So this, I just discovered this with you guys. I don't think I was aware of this before. Man, you could make some really nasty problems on the basis of this obscure bit of trivia. Ooh, yeah, I like this. All right, I'll behave. Anyway, you guys have questions about homework, yes? Surely.
Why so many questions on
All right, well, let me go solve some more problems for you guys then.
How do you calculate by hand though?
Calculate what?
Logs by hand.
Oh, well, if you want to calculate logs by hand, then you need to have one of these. This is it's called a slide rule.
Okay.
And see, you go like this, and then you can like stare at the things on it. Have you guys ever used a caliper?
Yeah.
You know, you get the lines to line up. It's something like that. I don't actually know how to use it, but Dr. Putney let me borrow it. So this is a slide rule. Up until the mid-'80s, this is how everybody calculated logarithms.
Really?
Except for a select few people who happened to have an electronic calculator, which were magical because you didn't have to use this to calculate a log. Professor Dromby told me that she had a physics student recently take a quiz in physics using a slide rule.
Wow.
It was on his bucket list, apparently. It was a bucket list to pass a quiz in physics using just a slide rule, which I find intriguing. It's given me ideas about bonus points for future courses, like, oh, do you have any extra credit in your physics course? Why, yes, I do. If you can pass the next test using a slide rule, you get 20 bonus points. Of course, the bad thing is that person will inevitably fail. Is it something I said?
I gotta call my mom.
You're going to call your mom.
About getting us.
It's important. You should go talk to your mom. That's good.
Yeah, I gotta call my dad.
What about getting a slide rule?
About getting a slide rule?
Hello, Dad. I gotta call you back.
So. is
Although,
it
Dr. Put-
deeper without those?
Dr. Putney has also mentioned that, you know, there are videos on how to use this on YouTube if you want to learn. Although I think the idea of using a computer to learn how to use a slide rule, it just seems kind of wrong. All right, so let's see here. Let's work another problem. So this this is actually not too bad a question for a test in some sense, but this one over here is I think more sort of in the world of like a bonus question on a test because it's just ugly. All right. Let's look at some more problems. I know one we haven't solved in here yet, but I almost got stuck on. We should talk about. Where'd that thing go? Oh, here, before I get to that, let's do these simple ones. Number 26. This is not one I got stuck on, but it's good to talk about. Log base 2 of 16. Log base 3 of 1. Log base 10 of 0.1. Log base e of 1 over e squared. And log base 1/2 of 8. So I already told other sections, and I'll tell you guys again, like I'm not going to ask you questions about log base 1/2 on the test, all right? But there is some in the homework, so I should spend a second here talking about it. So we're just supposed to calculate these things, basically without a calculator, right? So here's how it goes. This is what? Log base 2 of 2 to the power 4. Which is what? This is 4. Madeline, what is this?
0. Right? Is it
Well-
0?
0. Yeah, you got it. The log base anything of 1 is 0, right? Okay. How about the next one? What would we do for there? There used to be a math professor here who his lecture style was to just like sporadically call on all of the students indiscriminately. Like you were not safe. He calls on everybody.
To do what?
People are kind of terrified of him. What's that?
To do what?
Just questions in class. Be like,
Okay.
how do you do this, Francisco? For example. Put it in decimal. It already fraction form. I'll take your fraction form and raise you an exponential form. So that's 10 to the minus 1, right?
Oh.
So 1/10
Okay.
is 10 to the minus 1. And now what's the answer? The answer is minus 1, right? Yes. And this one, log base e is natural log, right? And that is e to the what? E to the minus 2. And remember natural log of, minus 2 is the answer. This one is weird. So here I'll show you how I think about it, and you can take it or leave it, okay? But this is how I think about this one. I go, all right, so I need fractions, yeah? So 8 is 1 over 1/8. Yep. And that is 1 over 2 to the third power. Which is really log base 1/2 of, 1/2 to the minus 3 power.
Okay.
So the answer is
Minus 3.
-3, yeah. Now, what if you don't want to think like that? What's another way you could do this problem? We could use the change of base formula, right? So like log 1/2 of 8, we could trade for, I don't know, log base 8 of 8 over log base 8 of 1/2. Oh, I guess that really wasn't much help, was it? Because I still don't have a nice, well, what is 1/2 relative to 8? I mean, the cube root of 8 is 2, right? So this is really like log base 8. I could simplify this. I'm just writing it again. And 1/2 is really, 8 to the what? Minus 1/3 power, right? See, because this says 1/2 is 1 over the cube root of 8, which is, 8 to the minus 1/3 power. But log base 8 of 8 is 1. And log base 8 of 8 to the minus 1/3 is what? Minus 1/3. And so the answer is -3. I don't know. Is that better? Is the first way I did it better? Any way you slice it, the problem's got this weird fraction of a fraction thing going on. Yep. The what? Any more methods? Well, there's always another method.
No, the only one.
But I think that'll suffice for those. Let's see here. Let's look at another. Oh, the one that I almost get stuck on sometimes is the following. And I don't think we didn't quite come to an example like this last class, So definitely, this problem's kind of important. It's really the only one that's like this, number 29. And so here it is. It's log base x of the 9th root of 7 equal to x. So how do you solve that? Oh, not x, not equal to x, my bad. 3 is on the other side. Oh, man. I'm sorry. I'm a dummy. I copied like half of one problem and half of another. I'm an idiot. Let's see, 64 over 343. Yeah, I wouldn't even know what to do with what I wrote down there. It's not hard to write down problems involving exponentials that have no solution. For example, 2 to the x equals to x. You can't solve that using elementary means.
Is it impossible?
No, it's definitely possible. Graphically speaking, 2 to the x looks like this, yeah? And, yeah, you're right, it is impossible. Here, put a minus in there. Okay, now it definitely has a solution. Fair enough. The other one couldn't be solved because it's just impossible, but this one definitely has a solution. It's like right there, but what is that? Pretty much you can only find that using a numerical method. So there's no nice answer to this. There's an answer in terms of things called Lambert W functions or something, but basically people invent a new function to give the answer a name is what happens. But how do you solve this one, number 29? So this is just an example of, not everything has nice solution. And you don't even have to have formulas which are all that complicated to get things not have solutions. That's a pretty simple equation, 2 to the x equal to minus x. That's a pretty simple equation. Okay, how do you solve this? Do you guys know? Well, what someone in the 815 section told me is, oh, raise both sides to the x power. And I was like, oh, well, thank you. That's perfect. So I take this to the x power, and I take that to the x. X to this, x to that. And then so I have x to the log base x. Those are inverse functions. They cancel. And we get 64 over 343 equal to x cubed. But I think maybe even a better way to say this is that if we just erase my x's here for a second, right? And look at this. This logarithmic equation, this is the corresponding exponential form of the equation, right? There are a lot of problems in your homework that ask you, write the logarithmic form of the equation given the exponential form or vice versa. This is an example of that. So this right here is the exponential form of the above logarithmic equation. And then how do you solve that? Well, you just take the cube root of both sides, yeah? So we have x equal to the cube root of 64 over 343, which is equal to the cube root of 64 divided by the cube root of 343. The cube root of 64 happens to be 4. The cube root of 343 happens to be 7 because 7 cubed is 343. So the answer here is 4/7. But this one's really weird compared to all of the other problems. Like almost all of the other problems don't have the base as a variable, right? Like the base is given to you. It's 2, right? It's 3, it's e, it's 10, whatever. I think the only other problem we looked today where the base was unknown was my made-up uglified problem in some sense. Okay, number 18's got a little bit of a mystery. It's got base 2 or base 3, but anyway. So I hope that's enough. I hope you can finish the homework. I hope you are able to understand what you need to about logs and exponentials this weekend. You too?
Have a great weekend, sir.
I'll try.
Yeah, I'll call my dad real quick, though.
You had to go call your dad? Uh-huh. Oh, and to answer your question, Francisco, like we can linearize the logarithm using calculus. Like there's a way.